All right, so we've got this 14.1. Now, one of the interesting things about 14.1 is it's a good review of some other stuff. So since we've got the final coming up, this is really, really good. Okay, so who remembers? So we've got some data here, age and cholesterol. We're trying to find out if age and cholesterol are related. Who remembers how to find a scatter plot? It was like 2 months ago, right? Colton remembers.
Yeah.
Okay, you're going to highlight your data. Here, I'll give you a little bit of a clue. Insert, okay, that was good. Scatter, and you pick the first one. All right, coming back. Now, we probably should label this properly. Do you remember how to label it?
X-axis.
Click on the plus sign. Add some axis titles here. What is this? Age. And this is cholesterol. And then age versus cholesterol or something. Okay. Now, Jacob, do you remember how to come up with the correlation coefficient, the easy method?
You go to the plus thing in the top right. Then you bet you just find
No.
the trend line or something. Is that different?
That's different. Well, that's actually the next step. Ashley remembers how to get the correlation coefficient. No, you don't want to click on the graph. There we go. Thank you, Eric. Coral, right? Equals coral. Take it away, Eric.
Just do age and then
Click
cholesterol.
the age, comma, cholesterol. So my correlation coefficient is 0.7178. And you would say that was strong, moderate, weak, or no? You'd say that's barely strong, right? Okay. Now, Jacob, we'll come back to you. How do you find the ordinary least squares equation?
You go to the plus sign on the graph.
Okay.
And then you go to trend line.
Trend line. I didn't know you could go that way.
And then I think you hit the arrow next to
Hit
it.
the arrow next to it.
And then more options.
Okay.
And
That's a new method. I never taught you that way, but that
just
works.
Display R squared value on chart.
R squared.
Equation.
An equation. You really want the equation more than the R squared. But let's just review here. What does R squared tell you?
Mostly all the dots actually fall to the line.
No, the scatter plot tells you how closely they fall to the line. What does R squared tell you? Hunter remembers. Oh,
Error here.
yeah, we got a lot of studying this weekend, right? What do?
Error here.
Exactly, that's what I'm looking for.
It's correlation squared.
It is the correlation squared, but what does that tell you?
Just give it to us.
I was going to pick on Michael.
Is it like the direction?
Direction, well, the scatter plot tells you the direction. Samantha remembers. No, Sean? No idea. Okay, it tells you what percent of variation is explained by the model. So let me ask you this. What percent is unexplained? 49%, right? 48.5. Okay? So only half the variation is explained by your age. The rest of it's unexplained. All right. So, all right. So what we want to do, yes? Question, David? He's showing you? All right. So we've got here our regression equation, which is y equals 1.3991x plus 151.35. Okay? So once again, what is the slope? The slope equals 1.3991, right? That was a nice, easy way to find it. Well, remember that I'll probably ask you on the final how to find the slope. You think you could use your formula sheet to find that? Probably if you practice this weekend. Okay? Practice this weekend. I don't want to cover that yet. But here's what we want to do. We want to do a hypothesis test on the slope. Okay? That's our goal today. Everything up to now has been a review. Okay? All right, so I'll give you the equations in a minute here, but let's go through our 7 steps. Okay? Step number 1 is this, categorical, quantitative, or regression. Should we vote? Who says it's categorical? 1, 2, 3. Who says it's quantitative? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who says it's regression? You changed your vote. You voted twice. 1, 2, 3. Finally, it's about time we got some regression in there, isn't it? Okay, what does a scatterplot give you? What is this? What is this equation? That's called the regression equation, right? We're doing regression this time. All right. Okay, regression. So now our null hypothesis should be what? See how good guessers you guys are. Yeah.
If that was saying instead of like a number for the cholesterol, if it said they had high cholesterol but not yes or no, it would be categorical.
That would be categorical if it was yes or no cholesterol, yes. We're getting an actual number here. Okay? All right, so what do you think the null hypothesis should be? Slope doesn't change from what? Now let's think about what regression tells you. So we said that 51%. What if the regression was 0? Excuse me, not the regression. What if the correlation coefficient was 0? 0 squared would also be 0, right? You would have no explanation. There would be no relationship. Okay? So we're trying to determine, is there a relationship or is there no relationship? Okay? We're specifically testing the slope. So what letter should I use? M. What should M equal? 0. Very good. And the alternative hypothesis? M does not equal 0. Okay, now let me just mention this really quickly. I like to use the letter M. However, in the book, they like to, so they use the equation y equals b 1x plus b 0. Or do they do it the other way around? I can't remember. Let me make sure. Yeah, I did it right. Okay. So they would argue that the null hypothesis would be b1 equals 0. The alternative would be b1 does not equal 0. I prefer the letter M because I like y equals mx plus b. M equals 0, M does not equal 0. So this is what the book does. This is what I do. I'll take it either way. Okay? That's my preferred, but the book, and here, let me explain why the book does this. Because when you get really into advanced statistics, you're not going to limit yourself to just 2 variables, okay? You're going to say y equals b0 plus b1 x1 plus b2 x2 plus as many as you want. You just keep going with the b's. You can use, b30 if you want to have 30 variables, okay? So that's why they do that. But I just like to use letter M because y equals mx plus b. That's kind of what you guys are familiar with. Okay. All right. So anyway, Now, let's talk about what type of test do you think it should be? Test. Should it be a z, a t, a chi-square, or an f? Okay. Let's vote. Who thinks it's a z? Nobody? Who thinks it's a t? Nobody? Who thinks it's a chi-square? One. Who thinks it's an f? One. Two. Okay, you're all wrong. It's a t. Why do you think it's a t? Because what? We're not given a population standard deviation. What's the standard deviation of your slope? Beats me, but that's what we're going to answer right now. Okay? So let's talk about the equations we're going to use here. Okay? So, all right, so the basic equation is T equals, I'm going to write it this way, M1 minus capital M1 over the standard deviation of M1. That's what I prefer to give you. However, in the book, let me make sure I write this right, what the book does, because I'm using M for slope. In the book, they say here, T naught equals B1 minus beta 1, and I don't want you to get that confused with beta, because beta is what normally? It's a type 2 error. It has nothing to do with our type 2 error in this case. Over S sub B1. So that's the equation on your formula sheet. I like this notation better, okay, because it's definitely slope. We use this because you can have multiple. If you're doing a multiple variables, that's the formula you're going to use. So this kind of makes a little bit more sense. But we're just doing simple stuff. I like that better. Yes.
Well, I don't get why we're testing this because we just found the slope.
Okay, so we're trying to determine if the slope is significant. Significantly different than 0.
So if it's like really close to 0, then we could just say it's here.
Yeah, well, not necessarily, because we don't have a very big sample size. Remember, how big is my sample size here? I've got a sample size of 14, so I don't have a huge sample size. This is a pretty small thing. I've got a sample size of 14, so I want to see is my slope significant from 0, and it might not be because the sample size is so small. Okay, all right. So let's go back to here. All right, now we need to figure out what S of M1 is. Standard deviation for your slope. S of M1 equals S sub E divided by the sum of the square root of x minus xi hat, quantity squared. And now you say, well, what's S sub E? S sub E is the square root of the sum, and I'm going to write it this way, of your residuals squared divided by n minus 2. Okay, so we're going to do residuals. You got who remembers residuals? I should hear a big groan. Really? Why can we do that again? Question for you. Okay.
So you have the square root there. Are we doing all of x minus x of i's in that square root, or?
Yeah, we'll go through it.
Okay.
Okay. All right. So let's go through all this stuff. Okay. Oh my gosh, you guys took too long on the quiz.
Don't make it so long.
I only gave you 2 questions. They were both multiple choice. Okay. Holy cow. We really only do have 2 minutes left. I didn't notice that. Okay, well, let me just ask you this in the 2 minutes. I guess we won't finish this today. Because we got a lot of calculations to do. But, so today you can think of as mostly a review day. Who remembers what a residual is?
No one.
Sean,
Does that do with like observed and expected?
observed and expected to keep going.
Residual.
So as we look at my scatter plot, what's the residual? Like, if I look at this point right here, it's the distance between this point and the line, right? So you remember? So this whole, everything here we're doing is a review, except for we've got some new equations here. Here's what I will say. Yeah, so we're going to have to figure out the predicted for each one of those, and then we're going to have to figure out the residual. So your homework tonight, okay? You can try to do some of this, but definitely review chapter 4, because pretty much, except for these equations that I've given you right here, everything else is a review, okay? So review your scatter plots, review how to do a residual. It's going to make our life tomorrow easier. We got to have a quiz, right? I got this off
Or we
something
have
out.
no
Maybe we
quiz,
should
have
just
more
have a
time.
quiz on like residuals.
Or we have no quiz, have more time to go over the material.
Yeah.
I agree.
Well, we could, if we did that, we could probably cover 2 sections tomorrow. Huh?
Yeah.
Let's not do that.
Let's not do that then. But then we get all next week to
Yeah.
review.
There's
So
no
that's not
test
bad.
next Thursday, right?
Yeah, but there's a big test right after
Yeah,
that.
yeah. But I was just,
I'm trying to get ready for that one.
yeah, yeah.
Okay. So yeah, do yourselves a favor, review chapter 4 on residuals. That's going to be a big important thing tomorrow as we finish all this stuff. Okay? So see y'all tomorrow.